Hello everyone. In this video, I will be talking about the Newton's third law of motion. According to Newtonian mechanics, forces never occur singly, but exist as pairs. We can consider an example. In this example, let us consider a spring that is compressed between our hands. When the spring is compressed, we can feel an opposite force acting on our hands by the spring. Similarly, we apply a force to the spring to compress it. So, the mutual forces between two bodies are always equal and opposite. In this example, the forces between our hands and the spring are always equal and opposite. Now, we can see the statement for Newton's third law of motion. The statement of Newton's third law of motion states that to every action there is always an equal and opposite reaction. As shown in this figure, let the air in the air-filled balloon is let out. The air exerts a force which makes the balloon go up. In this case, the balloon goes upwards, that is the reaction, while the air pushing downwards is the action. Now, the action and reaction are forces which occur at the same instant. These two forces occur at the same instant. Action and reaction forces act on different bodies and not on the same body, as we have observed in this example. The action and reaction are on different bodies. Now, we can see the law of conservation of momentum. The second and third law of motion lead to an important consequence, which is the law of conservation of momentum. We have already seen that the second law gives the change in momentum is directly proportional to the force applied. Now we can consider a gun firing a bullet. In this case, the gun exerts a force on the bullet which propels the bullet forward. Similarly, the bullet also exerts a force on the gun which makes the gun go upward. The force is applied at the same instant, and we can state that the recoil momentum is equal to minus PV, which is the bullet momentum. Since the initial momentum of both the gun and bullet is 0, the change in momentum, recoil momentum, for in the case of gun and the bullet momentum in the case of bullet, or otherwise PA plus PB is equal to 0. Thus, the total momentum of the gun-bullet system is conserved. The total momentum of an isolated system of interacting particles is always conserved. This is the law of conservation of momentum. Now, we can see equilibrium of a particle. A particle which is acted upon by forces, many forces tend to be in an equilibrium when a certain situation occurs. That is, equilibrium of a particle in mechanics refers to the situation when the net external force on the particle is 0. According to the first law, this means that the particle is either at rest or in uniform motion. If two forces are acting on a particle, for example, if two forces F1 and F2 act on a particle, equilibrium requires that F1 equal to negative F2 or F1 plus F2 is equal to 0. That is, the two forces must be equal as well as opposite. Now, equilibrium under three concurrent forces F1, F2 and F3 requires that the vector sum of the three forces is 0. That is F1 plus F2 plus F3 equal to 0. As shown in this figure, we can see that the sum of F1 and F2 by parallelogram law of addition is given and F3 is negative to it. Hence, here F1 plus F2 is equal to negative F3. In this case, this particle is said to be in equilibrium. So, this is the end of this video. In this video, I have explained the Newton's third law of motion as well as the law of conservation of momentum and the case of equilibrium of a particle. If you have got any doubt in any of the topics discussed in this video, please comment in the section below this video. Thank you.